Hi, it's Keith. I'm trying to get my head around because I don't really understand in the United States about this 200 amp bypass, because I read a lot of articles about it, and at Sunsync we've got hundreds and hundreds of thousands of systems installed, and all of our systems are based on a bidirectional hybrid inverter, which can do both essential load and non-essential load. But I'm trying to understand something. So typically you have a fuse board, you've got your power, your meter coming in here, your lights, your sockets, your power point, your load, your aircon, everything coming off the fuse board. This is typically how it's wired. And if you're going to using, say, a traditional string inverter, then you're going to put a string inverter here, and it will connect directly to one of the points on the board, and then this will go onto your solar panels. Okay, and then it just connects to the board. That's a normal string inverter. This is very simple. But if you're going to put it into a full house backup, then what I understand is people, because I read about it and they say, well, it's actually a lot of wiring. It's not so simple. So what you're going to do is here you've got your main your really thick cable coming into your my drawings are terrible. You're really into your fuse board from your meter. So you're going to break that wire. You're going to disconnect it, and we're going to put in a big junction box here and a big connection here. And these actually will be a split phase, so it's actually it's neutral and live 1, live 2. And we're going to take this wire here, and there's another wire here, and obviously the neutral is another wire here, goes into an inverter, and here's another wire, another wire, another wire. And these are really, really thick, big, heavy cables. And so what we're going to do now is you're on about routing all the power for the fuse board by the inverter. But you're going to have to do something else. You're going to have to put because if something goes wrong here, you don't want to be without power. So I'm going to have to take all of these cables down and put them into another switch, which will basically be an override. So I'd have to put another override. So there's lots and lots of cables, but inverters hold back. It will 200 amp, and there's no other boxes. Okay, so some people like to do that. I get that. I don't understand why, but I'm a Brit. I've probably got it wrong. But the bit I'm really struggling with. So I drew here. This is sort of standard configuration here. This is actually inside a hybrid inverter. So inside a hybrid inverter, you've got your MPPTs. You've got your inverter, because the MPPTs are like little inverters themselves. I've got solar panels shown here. And in fact, my drawing here, this is all part of the hybrid inverter. So my question is, inverter's 15 kilowatts. So if you've got a 15 kilowatt inverter, and you say, but it needs to pass much more. So 15 kilowatts is what arguable maximum 60 amp. Okay, it could be less than that, but arguably 60 amp. So I've got a 15 kilowatt unit. If I want to put a bypass onto here, so if everyone says it's going to be 200 amps, so I'm going to put 200 amp bypass here. That means the grid, if this is closed, this bypass is closed, will bypass the load, and this will allow through here 200 amp. Wow, amazing. Whole house backup. But if I leave my house and my AC is on, which is AC refrigeration, that's where the high power is, and suddenly I get a power cut, power stops, then what happens is this 200 amp will attempt to pull the full 200 amp from the inverter. So it's no longer going to get it from here, because this relay, this bypass will disconnect. Because if there's no grid, this bypass will disconnect, and suddenly, this huge energy, and it might be 200 amp, it could be 100 amp or 150 amp, but whatever, this huge energy is suddenly going to be diverted to the inverter. All the power is going to the inverter. So if I'm away, I'm on vacation, or I'm at work, and there's a power outage, then the bypass will stop. Suddenly I'm going to hit a huge overload, almost like a short circuit onto the inverter. And what's the inverter going to do? Well, if the inverter has done its job properly, it will trip. And you've got breakers on the inverter and they're going to trip out. And it will trip out and all the power will be off. Chances are, what I read, because there's high inrush, you can often damage an inverter by this. But that's not for me to say for other brands, but technically it could be damaged because you're overloading the inverter. But the inverters are 15 kilowatt, so the tracks on the inverter are 15 kilowatt, everything's 15 kilowatt. Now, the inverter, if it's built properly, will have protection onto it and it will cut out very quickly. It may trigger the thermal fuses, it may not. But what actually is going to happen is you are going to put that full energy through that inverter and it will trip. So you come home and you've got no power. So then you've got to go and switch everything off, maybe empty your refrigerators if they're defrosted if you've been on vacation, and you can restore your electricity to your house. But it doesn't give you automatically protection. It basically gives you no real protection. And this is the bit I can't understand, but it does put the whole house through. But I don't get it. So let me just take this, let's get rid of this, and to understand a little bit more, because this is, I'm obviously missing a point, missing something, because why would you develop something that's going to fail? You can wire it in, and I don't understand this. But if you get one of our inverter, a standard inverter, an inverter actually has two components. It has a DC component, it has an AC component. And you've got a standard inverter. And with internally the inverter, you have a grid relay, and then you have your generator or auxiliary, and then you have your load. And there's three relays. There's a relay there. So draw that. Okay. It doesn't really matter. You've got a relay here, and here you've got some relays here that control, because these inverters are bidirectional. The power can go in or out of the relay. So what normally do is you have your grid connection here, and this will go into a fuse board. It will just go connect into a fuse board. It can go from here or it can go from here. In fact, it would be on this side, and this will go to your fuse board as a simple fuse on your board, single fuse, dead easy. But your load comes from the fuse board, from the different fuses, and we're using what we call a CT coil that prevents the exports. So this inverter will supply energy. Doing it this way, it'll supply energy to your lights, your sockets, everything else, your AC. But what we do here on the load, rather than do all this complicated wiring, we often put in a small secondary board. And on the secondary board, we may put our lights, maybe alarm, maybe the kitchen, or maybe some for refrigerators. So we cover some basics on here, and it's very, very simple. There's very little wiring to do, and this load would go into here. And so what happens is, when the sun is shining, the sun is powering everything. All of it's being powered from the sun. But if you have a power outage, then the energy disconnects from the grid, which it will do, but you're not going to get a sudden massive rush, because the inverter is matched to the load. You match the inverter. If your load here is 15 kilowatt or 10 kilowatt, then your inverter will be, say, a 10 kilowatt or 15 kilowatt. You match it to the load. And therefore, when you have your load, a power outage, it will carry on supplying. You're not going to be without power. And then, if you say, right, okay, but it doesn't give me a whole house backup. But if you really want to be able to select other things, you could do that with a series of switches, but you have the choice and you can switch it in. You're not going to actually have the thing blow up, explode, or damage, or fuse, or trip, or whatever. It doesn't matter. It's not good. And by doing it just the conventional way, by using AC couple on your loads, on your grid side, so the energy, because the energy from the inverter will go both ways. It goes both ways. The old method of many years ago, before we have hybrid inverter, then you could actually you put everything through the inverter, because there was no way to AC couple. But now we have a hybrid inverter. It can AC couple. The inverter can supply both onto the grid side and the load side. It doesn't need a whole house backup as such, because that's its setting to fail, and it's setting to give you a trouble, because at the time when you really, really need that inverter to function, it's going to let you down. And you know, to doing it this way, if you want to add a couple of other rings or whatever you say, oh, then just do that by simply a switch. If you want to, because otherwise what's going to happen is when you have a power outage, things going to trip. If it's an elderly couple, they might have to go to the garage and be able to reset things. They might know what to do. If you're on vacation or you're at work, it's going to fail. You know, your alarm system will run as battery, that will fail. Everything's going to fail. Your internet will fail, and nothing's going to be reliable. But by doing it the way that everybody in South Africa and the UK and many parts of the world do it, rather than putting a whole house back up, consider this. You know, please look at the video and tell me I'm wrong, and tell me why it's better to do it this way, because I just don't understand. Anyway, thanks for following.